Okay, so radical functions. Radical functions. We've dealt with this type of situation already with absolute value. We dealt with this type of situation with exponential functions. And so what we're trying to understand is some clear patterns between shifting all the different kinds of functions. So it all starts with a pattern. So our pattern is going to be f of x equals the square root, and in the radicand you have x minus, then take your red. Anybody remember what letter goes here? H, right? X minus h, and then outside in green plus k. And what you want to remember is this is the horizontal shift. This is the horizontal shift. And your K is your vertical shift. Not only that, the vertex has values of HK. So the coordinates of your vertex are HK. It really helps to graph these if you'll start with the vertex. That's important, and it's going to allow you to understand what's going to happen to the function. Okay, so what happens with a square root function? All right, just like always, we've got an input, and we're trying to figure out the output. The x's are the input, and the y's are the output. All right, it's always wise to start with your vertex. Well, here's what we're graphing, y equals the square root of x. Here is what you should be thinking. All right, this is what you think. Because when you take the left one and make it fit the pattern, then you understand that the h was a 0 and the k was a 0. That's why you don't see anything there. If there's nothing for the h, it's a 0. If there's nothing for the k, it's a 0. Nothing is 0. So again, we'll give you the one on the left. You should be thinking the right to figure out the h and k value. Nothing given for the h is 0. Nothing given for the k is 0. So I already know this first point is 0, 0. It's my vertex. And I'm going to put a point on my graph at 0, 0. So go to your graph and stick the point on your graph at 0, 0. We'll do the rest with an XY chart. So remember, to do 1, we take the function, y equals the square root of x. And where the x is, we stick in the 1, right? We're just taking the function, y equals the square root of x. And where the x is, we stick in 1. So class square root of 1 is 1. So now we have the point 1, 1. Go to your graph, go 1 to the right and 1 up, and put your second point. Now, I know what I'm doing here, and therefore I'm choosing values that are more graphable, more easily graphed. I could use 2. Should have your calculator out already. If you don't, go ahead and bust it out. If I use 2, I don't want to write square root of 2 in the blank, because who knows where to graph square root of 2? Not too many people. So punch into your calculator square root of 2, and what value do you get? It's going to be 1 point something. 1.4. Okay. I mean, you could do that. But I know that the next thing that I can evenly take the square root of is 4. And so that's why I went to 4 next. Because we all know the square root of 4 is 2. And so the y value is 2. So when x is 4, y is 2. And plot that point. When x is 4, y is 2, and therefore plot the point 4, 2. X is 4, y is 2, and plot that point. Again, you can do square root of 5. That's going to be 2 point something. You could do square root of 6, 2 point something. Square root of 7, 2 point something. Square root of 8, 2 point something. The next one you get to that's an integer is when you do the square root of 9. And we all know the square root of 9 is 3. And so I know at 9, I'm at 3. So I'm going to go 9 to the right and up to 3 and put a point there. Now, we figured out already that 0, 0 was the vertex. Therefore, I know that this is the graph of this. Always an arrow out to the right, because this thing goes on forever. But just to make a point, let's suppose you didn't know that the vertex was 0, 0. Well, how do we know if this function doesn't go to the left? Well, you'd have to try a value on the left. And so that's why I stuck the -1 there. So what's the square root of -1? If you don't know, punch it into your calculator. Do square root of -1. What does your calculator say? Error, syntax error, what else? No, domain error, okay? Yeah, this is an imaginary number. So this is no solution. It can't be. There is no real number. It's really no real number. And there are no negative values. Can you take the square root of -2? No. Square root of -7? No. Square root of -9? No. Square root of -100? No. Square root of -0.00002? No. Okay, we can't. Can't take the square root of any of those. Okay. So how do we say the domain and how do we say the range? So I think we've been doing ours. Have we been using set builder notation? I can't, got to keep my classes straight. Have we used the brace and then X, vertical line X? Have we used that here? Or did we just go, did we just go like this? The domain is D is X greater than or equal to 0. Did we do it that way? We used the brace. All right, so the values are any value 0 and greater. Do you agree? You have an X value of 0 then greater, right? Where does this thing start? The low value of the X's is 0. It does include it, and it goes forever in the X direction. So what is the domain X greater than or equal to 0? If you did it in set notation, it would be brace X. Vertical line means such that, and then still X is greater than or equal to 0. That's in set notation. The other way is just inequality notation. When you get to Algebra 2, we'll show you how to do it in interval notation. Just a different way of saying the same thing. Okay, do you agree you can't have an X that's negative? And that's why we start at 0 and we go bigger. Anything bigger than 0. Can X be 2 million? Yes. Can X be 8 billion? Yes, because look at the arrow. It's going forever in the X direction. What about the range? What about the range? Well, look at the graph. Are there any Y values below 0? Yes or no? You see any Y? Does the graph involve any Y values less than 0? And the answer is no. The graph's not down there. There's no part of the graph down here. What's this thing doing? It's heading out to the right, and it's heading up slightly. It's going more out to the right than it's going up, but it is going up. So we have no values less than 0. So our range is going to be Y greater than or equal to, and how does this thing end? What's the biggest Y value possible? What's the biggest Y value possible? 0? Well, this Y value is 1, so that throws that off. This Y value is 2. This one is like 2.4. This one's 3. What's the highest possible Y value? Infinity. Even though it's going out to the right a whole lot quicker than it's going up, guess what? It has forever to go up. And guess what? If it has forever to go up, it will get to infinity. So this is Y greater than or equal to 0, which means you have values of 0 all the way to infinity. And again, if you were to write it in set builder, set of all y's now such that y is greater than or equal to 0 if you write it in set builder notation. So that's the base model. That's our basic shape. You should take a snapshot of that and get that in your brain. That's the norm right there. Okay? It's the base model. Are we shifted anything horizontally? No. Are we shifted anything vertically? No. That's the base model, and get that in your brain. All right, let's take a look at some translations. So we'll take these one at a time. So take a look at A there. So you got your function y equals the square root of x minus 5 plus 4. So let's figure out the vertex first. So somebody raise your hand and tell me the coordinates of the vertex. Abby? 5, 4, right? Not negative 5, 4. It's what you read after the negative sign 5, 4. So somebody tell me the horizontal shift. Ethan? What do you mean by plus? Give me a direction. Up, down, left, right. Up 5? No. To the right 5. Correct, because it's a horizontal shift. So we go right 5. Somebody tell me the vertical shift. John?
Down 4, or up 4, sorry.
It would be up 4, right? A positive is up, negative is down, so up 4. Horizontal shift, positive is right, negative is left. Vertical shift, positive is up, negative is down. All right, so B is below it, right? So go ahead and write the coordinates of the vertex. Uh-oh, no color. Oh, wait. I did A, B, B, C. That's really, really good. Do your notes say that too? All right, first edition. Love it. Isn't that great? Here, let's go to the right first. Let's keep doing that. I think that's where I intended B to be. So let's do the one to the right. Let's do the B to the right. All right, pretty simplistic. Write the coordinates of the vertex and then fill in the horizontal and vertical shifts. I'll do it up here as you guys do it yourselves. Try not to look unless you need it. Try to do it yourself. Think it through yourself. And hopefully you thought it's 1, negative 7, and therefore it's right 1 or 1 right, and down 7 or 7 down. Everybody okay with that? So again, you're just reading H and K. Just reading H and K. All right, with our second B here down to the left, go ahead and write the coordinates of the vertex, and then go ahead and write the vertical and horizontal shift. Go ahead and write the coordinates of the vertex, and then go ahead and write the vertical and horizontal shift. And we've been through this before. I hope you wrote negative 2, negative 3. Therefore, you are left 2, and you are down 3. How many got that correct? Because, again, you have to read the H value after a minus sign. But the function is simplified. The way we got to a positive 2 is because it must have been x minus a minus 2. Therefore, the H value was negative 2, and the K value is whatever the K is, which is negative 3. Okay? Always the case. You read H after a negative sign. All right, so go ahead and do the C there, which really is D. And again, you do it at your seat. I'll do it up here. Try to do it without looking. So same situation, right? Because there's a plus sign, it must have been minus a minus. So negative 5.2 and 2/5. Left 5.2, don't say left negative 5.2. Remember, the negative says left. So left 5.2, up 2.5. How many got that one right? Okay. So again, just be careful there. It's a little tricky, I know. But again, we keep doing this and doing this and doing this, and we'll do it all the way through Algebra 2 as well when we get to Algebra 2 in a couple months, in a couple years, months, or other. All right. So now let's get to graphing with these shifts. All right, focus in now. Don't daydream right now. When you graph these, you want to start off with the vertex. You want to start off with the vertex. So why don't you out loud tell me the coordinates of the vertex? 2, -1. 2, -1. That's how you want to start. So the first thing you want to graph on your graph is the vertex at 2, -1. Oops, I want that to be red. So 2, -1. This is your start. All right. In your brain, you can write this if you want. I'm going to write pattern. In your brain, you should think this. Right? That's the pattern we just did a minute ago, isn't it? It's what should be in your brain. That's what you're expecting this one to do. So, what do I use for my XY chart for the first value? So the first value, you just want to go one past your vertex. That's always the case. Go one past. We're already at 2, aren't we, on the X? Therefore, what are we going to use for X? 3. 3. Make your first value 3. Look, I know the pattern. It goes from the vertex to the right. You always want to go one past your vertex. I'm at 2. Go one past and start at 3. Go ahead and take your function and substitute in 3 for the X. You got 3. Whoops. You end up with a 3 minus 2 and then outside a minus 1. So you end up with the square root of 1. Class, the square root of 1 is 1. And 1 minus 1 is 0. And now I have the point 3, 0 right there. I like it. It's fitting my pattern. Now, here's where you got to be smart. We went 1 from the vertex because we can do the square root of 1. What's the next square root we can do easily? Square root of 4. So we want to go 4 from the vertex. So I'm starting at 2. To go 4 more puts me at, this is the easiest way to do it. I'm going to use 6. So again, let me go through that thinking. What's the next square root I know? Square root of 4. Therefore, I want to go 4 more from my vertex. Where am I at already? 2. 4 more is 6. Because notice what happens when we plug it in. Use my color here. So now when I stick a 6 in, and I go 6 minus 2, it gets me to that 4, right? Square root of 4 is 2. 2 minus 1 is 1. And I'm at the point 61. This is the easiest way to graph them. You could do these in between numbers, but again, these in between numbers are going to be all decimals. You can use your calculator, but this is the best way. All right, so we know the square root of 1 is 1, the square root of 4 is 2. What's the next one? Square root of 9. So what would you use for your X value? You're at 2, you got to go 9 more, you end up at 11, right? This is the easiest way to do it. Is it the only way to do it? No, it's the easiest way. So again, now I'm sticking an 11 in for my X. 11 minus 2 is 9, square root of 9 is 3, 3 minus 1 is 2. and plot the point 11, 2, and draw your curve. And hit your points. All right, I went too fast, missed a few of my points. Hit your points. Don't go too fast. Hit those points. All right. What would the domain be? Somebody raise your hand and tell me the domain. We'll do it the easy way. I'll just do it with the x. So what do you want to say? Somebody raise your hand, give me the domain. Come on, folks, think. Look at the x values. Pamela? X has to be greater than or equal to 2, right? It's all the values from 2 and bigger, isn't it? What are all the x's? From 2 and bigger. All right, what about the y's? Somebody raise your hand and give me the y's. What are all the y's? What are all the y's? Alexandra? Y is greater than or equal to, right? You added there, than -1. So y can be -1, but y has also all the values up toward positive infinity, which is y greater than -1. All right? Domain, what are the possible x values from 2 all the way to infinity? What are the possible y values from -1 all the way to infinity? You have to look at where the curve's heading. Where is it going? For the y's, it's the domain. For the range, it's starting at -1. It's going forever up. Greater than or equal to -1. For the domain, the x's, it starts at 2 and it goes forever right. Greater than or equal to 2. That's what you're looking at for domain and range. All right, so number 3. So now we get the same idea. How am I going to start? With my vertex. So write in the coordinates of the vertex. Did you write -3, -2? Why? Because again, you got to read it after a negative, and it's a simplified version of x minus a -3. You have the pattern in your mind. Again, what's my pattern? Like this. What I'm expecting, right? I always want to plot my vertex first. I go 3 to the left and 2 down, and I put my vertex. Right? Always want to plot the vertex first. Now look, when you're asked a graph on a quiz or test, is it going to say vertex? No. You have to think, I want to do the vertex first. Because if you don't, you're going to be lost in space. I'm just telling you, if you don't do the vertex first, good luck. You're probably not going to get the curve in the right place. Okay, that's where I start. Who remembers how to get the best next point to use for x? What do I use my XY chart now? What's the best point to use first off for x? John?
One to the right.
Well, tell me the x value. What x value do you want to use?
2.
Hang in there. Come on, John. What x value do you want to use? Where you at? What's your x value, John?
-2.
Is that what you want to use?
No.
-1, -2, -3, right? We're at -3. Therefore, our value is going to be -2. What's 1 more than -3? -2. Going to go 1 to the right. Go ahead and plug that into your original. Now I end up with 1 plus 3 under the radical minus 2. 1 and 3 is 4. The square root of 4 is 2. 2 minus 2 is 0. And so I'm at the point -2. And I used the wrong coordinate. What in the world am I doing? All right, hold on. I'm ahead of myself. It's at -2. All right, let's get back on track. -2 for the x plus 3 gives you a 1. Square root of 1 is? Square root of 1 is? Come on, think. 1 minus 2 is? -1. So we're at -2, -1. Right there. -2, -1. Okay, Again, in this problem, the best next value would be what? Somebody raise your hand and tell me what's the next best x coordinate. Ethan? If you use -1, you can. You're going to get a decimal. But you can. But we want to show this curve. Kaylin? 1. So we're at -3. Kaylin went 4 more, and that puts her at 1. So notice what happens when we use 1. Again, this is just a means of getting all integers, because we know the square root of 4. So 1 and 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. And we're at the point 1, 0. Right there. All right, can you tell me what the next best, what's the best x coordinate for the next one? Adam? 3 only gets you the square root of 6. So, and we don't like the square root of 6. Connor? 6. You got to go 9 from a -3. 9 from a -3 is a 6. Because again, you always have to think, where am I starting? I'm starting at -3. 9 more gets me to 6. 6 plus 3 is 9. Square root of 9 is 3. 3 minus 2 is 1. And that's probably enough, and we'll graph it right there. Always end up with an arrow on the other end. The left end is a point. All right, for time's sake, I got to go a little quick here. Domain, x greater than or equal to, say it if you know it. What's the x coordinate? -3. Range, y greater than or equal to, say it if you know it. -2. Some of you aren't asking questions, and you should have been all along, because you guys are not answering my questions, hence you don't know what's going on. So I'll try one more time. The domain is the x value and how far it goes to the right. What is the x coordinate at this point? -3, and it goes forever in the positive direction. Therefore, x greater than or equal to -3. What is the domain? The domain is this point and up. What is the y coordinate of this point? -2, meaning the bottom, the lowest y value is -2, and then everything bigger, y greater than -2. Again, if you don't get that, you're going to have to think for a little bit. All right, now we're going to do a couple quick things that are a little bit out of the ordinary. What does a negative inside do? All right, well, the vertex, thankfully, is 0, 0. That's good. 0, 0. Come down here, I don't care how far, just somewhere toward the right, and put the vertical y-axis. You don't have to put it exactly where mine is. It won't matter, okay? And I'm going to come too high and put the x-axis. I know that's where I need it, and so that's where I'm sticking it. You would actually wait to do your x and y axis until you got your points. All right, I do know I'm at 0, 0. Next point I want to do is 1. So be careful here. This is y equals the square root. I have a negative sign, don't I? And then the 1 I'm trying to put in. So what's up with that? What's the square root of -1? No solution. Can't do it. Can't do it. So what do? Say I'm stuck, don't know what to do. No, try some values the other way. Let me use -1. Now I get y equals the square root of minus from the formula and -1 for my x value, right? Minus a -1. Negative for the formula, yes. -1 for the x value. Minus a minus is a plus. Square root of 1 is 1. That worked. Now I have a point. And here I'm just going to stick in a couple values. So I was at 0, 0. I'm at -1, 1. Any idea what the next good point is to use? Ethan? Square root of negative 2 is like 1.4. Nick? Negative 4, because we're trying to get the square root of 1, square root of 4, square root of 9. This is really what we're after. You can use negative 2. It'll work. You just have to use your calculator. You're going to get decimal round-offs, but that's okay. So again, here we get minus a minus 4. Good. Square root of 4 is 2. And we get the point negative 4. 1, 2, 3, 4. Negative 4, 2. For time's sake, I'm just going to put it right there. Again, if I had time, I'd do negative 9 and finish it off. And that's what would happen to that one. So that's interesting. That negative inside made that happen. Now, we don't have time to do the next one, but I'm going to show it to you. This last one, notice a negative out in front. What does that negative out in front do? All right. So just put a vertical line here for the y. And just go 2 down from the top and put the horizontal line. I'm just going to show you. You can play around with the coordinates later. All right, put a point. I'm going to do it in green at 0, 0. Put a point at 0, 0. Put a point at 1, negative 1. See that negative out in front turns a square root of 1 into a negative 1. Go to 4, 1, 2, 3, 4, and put a point at negative 2. Go to 4 and put a point at negative 2. And for time's sake, I'll leave it at that. But if you go to 9, it would be at negative 3. That negative, what we say is this is reflected about y equals k. And in this case, k is 0. It's flipped down. That negative out in front does that. All right, you'll discover relationships like that tonight. Use your text as you need to. And there's the assignment.